Hey, you are watching AliAziz YouTube channel.
Control plans for fresh and experienced candidates. AliAziz Quality Education YouTube channel providing you the job's best interview related videos. So don't forget the subscription button. Control plan development. Introduction to control plans. What is a control plan? Why develop a control plan? How to develop a control plan. Introduction to control plans. Most companies are looking for methods to reduce cost and eliminate waste in their processes. In the business world today, controlling waste and maintaining a high level of quality is imperative for a company to succeed. The cost of doing business is ever increasing. Rising costs of raw materials combined with labor and equipment costs have brought scrap reduction into the critical to business category. The cost of steel alone has more than doubled in the last 2 years. Therefore, it has become increasingly important to assure that parts are being produced that conform to customer requirements every time. In addition, we must have the ability to detect a non-conforming part or assembly as well as a plan for responding to changing process conditions. The majority of manufacturing companies are experienced at detecting initial problems and developing corrective actions to correct the problem. But many fall short when it comes to sustaining those corrective actions or process improvements over a long period of time. In many cases, the process gradually returns to its previous state and the problems eventually resurface. The purpose of a control plan is to monitor processes and assure that any improvements are maintained over the life cycle of the part or product. Control plans are currently being utilized to ensure product quality in the automotive, aerospace, agricultural equipment, heavy equipment and many other industries throughout the world. A control plan is often a production part approval process, PPAP, requirement for suppliers of parts to companies in these industries. The primary resource for information regarding control plan methodology in the automotive industry is the Advanced Product Quality Planning and Control Plan Manual published by the Automotive Industry Action Group, AIAG. What is a control plan? The control plan is a document that describes the actions, measurements, inspections, quality checks, or monitoring of process parameters, required at each phase of a process to assure the process outputs will conform to predetermined requirements. In simpler terms, the control plan provides the operator or inspector with the information required to properly control the process and produce quality parts or assemblies. It should also include instructions regarding actions taken if a non-conformance is detected. The control plan does not replace detailed operator instructions. In some cases, the control plan is used in conjunction with an inspection sheet or checklist. The control plan helps assure quality is maintained in a process in the event of employee turnover by establishing a standard for quality inspection and process monitoring. Control plans are living documents that should be periodically updated as the measurement methods and controls are improved throughout the life cycle of the product. Control plan sheet format. Why develop a control plan? Developing and implementing control plan methodology has several benefits. The use of control plans helps reduce or eliminate waste in a process. Businesses today must reduce waste everywhere possible. The control plan improves product quality by identifying the sources of variation in a process and establishing controls to monitor them. Control plans focus on the product characteristics most important to the customer and the business. By focusing on what is critical to quality during the process, you can reduce scrap, eliminate costly reworks and prevent defective product from reaching the customer. When scrap and reworks are reduced, throughput of the process is inherently improved. Manufacturing efficiency is improved and your company's bottom line is impacted in a positive manner. How to develop a control plan? The control plan should be developed by a cross-functional team, CFT, that has an understanding of the process being controlled or improved. By utilizing a CFT, you are likely to identify more opportunities for improvement of the process. The control plan is more than just a form to fill out. It is a plan developed by the team to control the process and ensure the process produces quality parts that meet the customer requirements. The information contained in the control plan can originate from several sources, including but not limited to the following: Process flow diagram, Design failure mode and effects analysis, FMEA. Process failure mode and effects analysis, FMEA. Special characteristics matrix. Lessons learned from similar parts. Design reviews. Team knowledge about the process. Field or warranty issues. Throughout the life cycle of a product, the information contained in the list above frequently changes or the content grows. Therefore, the control plan must be a living document, continuously updated as new information is added. The control plan therefore is an integral part of an effective product quality system. The 3 levels of control plans. Prior to completing the control plan development, the team must determine the proper level appropriate for the process being controlled. There are 3 designations for a control plan level based upon what point the product is at in the new product introduction, NPI, process. They are as follows. Prototype. This level control plan should include descriptions of the dimensions to be measured and the material and performance tests to be completed during the prototype build. Pre-launch. This level of control plan should contain descriptions of the dimensions to be measured and the material and performance tests to be completed after prototype but prior to product launch and regular production. Production. This level of control plan should contain a comprehensive listing of the product and process special characteristics, the process controls, measurement methods, and tests that will be performed during regular production. The control plan format. There are many variations of the form used to document the control plan. Most of the forms used are in the Excel format, although there are custom software packages available for many quality tools, including control plans. The following section will provide descriptions of what general information should be populated in each of the blocks. The types of control plans vary depending upon the process being controlled. Control plan level. The appropriate box should be checked to indicate the level or type of control plan that is being developed. Control plan number. Enter the appropriate number that the control plan will be listed as in your document control system. Part number / latest change. The part number listed on the drawing should be entered in this box. In addition, the appropriate change or revision level should be indicated. The control plan should be reviewed and updated with each level change or revision of the part or assembly. The control plan should be a living document. Part name / description. The name and description of the part or process being controlled should be entered in this box. The process name is preferred if the control plan is covering a family of parts produced on the same process. Supplier / plant. Enter name of the company and plant / division developing the control plan. Supplier code. Your designated supplier code should be entered if the part is being produced for an external customer. Key contact / phone. The name and contact information, phone number, email, of the primary contact responsible for the control plan. Core team. Enter the names of the CFT that prepared the control plan. Supplier / plant approval date. Once the approval is received from the customer, enter the date approval was received. Other approval / date. Enter any additional approval information and date if required. Date original. The date the control plan was initially completed should be entered here. Date / rev. Insert the latest revision date of the control plan released in this box. Customer engineering approval / date. If required, obtain the customer engineering approval information and enter in this location. Customer quality approval/date, if required, obtain the customer quality representative approval information and enter in this location. Other approval/date, enter any additional approval information and date if required. Part/process number, the information for this column is referenced from the process flow. Part numbers may be entered for an assembly, and in some applications the process step number from the process flow is entered. Process name/operation description, enter information from the process flow diagram that describes the operation being performed in this column. Machine/device/jig/tool for manufacturing, in this column, identify the equipment, machines, fixtures, jigs and other tools required to accomplish the particular process operation listed in the corresponding row. Characteristics section. This section of the control plan describes the particular characteristics of the product or process that may need to be controlled and documented. The characteristic could be product or process related, and the data could be variable or attribute data. The difference between product and process characteristics is often confused when completing a control plan. Number. This column is used for assigning a number corresponding to information in the process flow, work instructions, or a numbered print. Product. Product characteristics are physical features or properties of an assembly or component part usually described on the drawing that can be measured when the process is completed. Not all the dimensions or features on the print should be listed on the control plan. The team should determine the key or critical characteristics and compile them from their various sources. Special, key, or critical characteristics come from the DMIA exercise, print reviews, product or process historical information and customer feedback. If there are no key product characteristics for the particular operation, leave this space blank. Process. In this column, the team should identify the key characteristics relating to the process. Examples would be the setting on a torque tool or the orientation of parts in a fixture. If there are no key process characteristics for the particular operation, leave this space blank. There could be multiple process characteristics listed for a single product characteristic. Key process characteristics can originate from the PMIA or team knowledge of the process performance. Special characteristic classification, enter the letter representing the appropriate classification for any special characteristics. The list of designations is below. D. Design. P. Process. R. Regulatory. OS. Operator safety. Methods section. The information contained in the methods section includes the specification to be measured and a plan for collecting the data and controlling the process. The data could be variable or attribute data. Product/process specification/tolerance, list the specification and tolerance as defined on the drawing, material specification, 3D model, or in the manufacturing or assembly documentation. Evaluation/measurement technique, identify the measurement tools, gauges, fixtures, and or test equipment used to evaluate the part or process specification listed in the previous column. A measurement systems analysis, MSA, is recommended to assure that correct, consistent usable data is being collected. Sample size, if sampling is required, list the corresponding sample size or number of parts or assemblies that should be measured/evaluated during the process. Sample frequency, if sampling is required, list the frequency at which the samples will be taken during the process. As an example, the frequency could be first, 25th and final, or it could be continuous. Control method/prevention, this column should list the prevention controls and or documents the operator will need to complete the process step. This should include work instructions, drawings, visual aids, etc. Control method/detection. The information in this column is critical for the effectiveness of the control plan. This column should list any detection controls determined by the team during the previous quality plan activities, including the DFMIA and PPMIA. The methods could include but are not limited to statistical process control, SPC, visual inspection, attribute data collection, error proofing, etc. A document or procedure number may also be populated in this space. The effectiveness of the control selected should be evaluated on a regular basis. Reaction plan. This column should specify the actions required to prevent production of non-conforming products. The actions should be the responsibility of the operator and/or their immediate supervisor. They should include at the very least how to label, identify, and quarantine the non-conforming material and the proper disposition of the suspect material, parts or assemblies. In addition, the reaction plan should include directions for properly documenting the incident and who should be notified of the non-conformance. Control plans can vary depending upon what type of process is being controlled. There are many different applications where the control plan can add value to the process. Below are a few examples of the different applications. Equipment setup process, where the major contributor to process variation is proper setup of the equipment prior to the production run. Equipment tooling dominant process, where the major influence on variation is the impact of tool life on the part or product design characteristics. Operator dominant process, where the variation in the process is a result of the knowledge or training of the operator and the proper controls. The control plan can be a very effective tool for reducing the amount of scrap generated by a process. It can be very useful at improving quality and helping contain any non-conforming product prior to it leaving the work cell. It is most effective when incorporated into a larger quality plan. The control plan is the same as any other tool, in that to get the most value you must know how to use it properly. Your teams will require training and coaching in order to implement an effective control plan system.